Yes, yes. Hello. Hello, people. Here we are again, More more exponents, right? Exponents and pretty soon, it's going to lead into I don't know where it is, but logarithms. Uh-oh, right? Yucky logarithms. But let's see here. What do I want to do? Kick things off here for today. Guess I'll do one more of these questions here. With rewriting each expression as a polynomial. Right, just chopping it up, people, right? Splitting them up, as I say. All right, so which one do I want to do here? Let's do 33, people. All right, 33. See what we got? Split them up. All right, divide each of the terms here by 2x to the power of 4. So that's a 1x5 over 2x4 plus 6x2 over 2x4 minus 4 over 2x4. Okay. All right. So, 1 over 2, we're just going to leave as is. We have an x5 over x4. They'll cross out. And you're going to have 1x left over in the numerator, right? We have 6 divided by 2 here is 3. We have an x2 over x4. All right, x2 over x4 will leave you with 2 x's left over in the denominator. And the last piece here, 4 over 2, right? We can divide that to 2 over 1. And we'll just leave the x4 there. All right, so what do we have here? 1x1 over 2. So I'm not doing 34, so I'm going to use that room. X1, right, or just x over 2 plus 3 over x squared minus 2 over x to the 4th. All right. So that's good. Once again, you want to move the x4 and the x2 up. Let's do that if you want. You want to pull out this coefficient of a half. Doesn't matter to me, to be honest with you. So, if you want to write it as 1/2 x plus 3x to the negative second minus 2x to the negative 4th, right? And you want to tidy it up a little bit, that's fine as well, So either way there, guys. All right, looking good there for number 33, right? That's number 33. Okay, so either one. All right, so this is stuff I've already done here, 35 through 40. Looks like stuff I've already done as well. Very good. This is more review, so skip into that. Here we go. This I need to do. All right, so factoring with negative and or fractional exponents. Okay. Factor each expression and express all answers here without fractional or negative exponents. All right. So factoring, people. You remember how to remember the factoring? Right? 5x cubed minus 20x squared. Remember how to factor that, people? Right? 5 and 20. Look at that, right? Do you know what you can do there? Isn't there a number in common, right? 5, right? 5. So what I'm trying to get at here, and it's taken me a little longer to say this, I don't know why, is GCF, right? 5 goes into 5, 5 goes into 20, right? Both numbers there are divisible by 5, which means you can factor out a 5. GCF, people. That's what I'm getting at. Greatest common factor. And now you have an x3, right? So you have an x3 here, and you have an x2. x3 is x times x times x. x2, right, is x times x. It's the greatest amount of x's that are in common with both of these terms, you know? Right? You can take 2 from here, 2 from here, right? You can take 3 from the x cubed, but you don't have 3 to take from the x squared. All right, so the GCF here between x3 and x2 is an x2. Right? So the greatest common factor here between 5x cubed and 20x squared, right, because you can do 5 divided by 5 and 20 divided by 5, right, is 5x squared. Right? That's your GCF. We're going to factor that out, right? We're factoring that out. 5x squared comes out. You know, in GCF, people, all we're doing here is just rewriting this in a multiplication form. I mean, that's all it is. So factor out a 5x squared, and then you just divide each term, right, in the numerator by 5x squared to get the remaining factor. So 5x cubed divided by 5x squared is x minus 20x squared divided by 5x squared is 4. And there you go. That's your factored form. And that's your answer, because there's, you know, they don't want fractional exponents. They don't want negative exponents, and we don't have that here with number 1. All right. Number 2. It's the biggest number we can divide both 4 and 12 by, right? That would be 4, right? The greatest common factor between 4 and 12 is 4, right? Another way to look at it is, write out the factors of 4, right? Think about, what we did in the last unit, 1, 2, and 4. Write out the factors of 12. 1, 2, 3, 4, 6, 12, right? It's the biggest number, right, they have in common is 4, right? And now we have an x6 and an x8. Right? So x to the 6th is that. 6 x's. I'm not going to draw these lines here. X to the 8th. Is 8 x's, right? It's the greatest amount of x's you can take out from both terms, right? It's the greatest amount of x's. You can take 6 from here, 6 from here, right? Can't take 7, right? Can't take 7 from both. So the GCF between x6 and x8 is x to the 6th, right? 6 x's is the greatest amount of x's you could take from both terms. All right. So a 4 with an x6, right? So that's your GCF, right? The GCF of both of those terms is 4x to the 6th. So we're going to factor that out, right? We're going to factor out a 4x to the 6th power. And then, once again, we'll divide both terms here by the GCF. Right? To get the remaining factor, 4 divided by 4 is 1. x6 over x6, if you want to cross that out, fine. Minus 12x to the 8th over 4x to the 6th. 12 divided by 4 is 3. x8 over x6 is an x2, right? Remember, we're just writing this in a multiplication format. So this product here should multiply to 4x to the 6th minus 12x to the 8th. We're not changing what this is. We're just rewriting it as a product. That's all. So does this have no fractional or negative exponents? These are good, right? I don't see fractional exponents here. I don't see negative exponents. So that's your answer, people, all right, to number 2. Now you're like, hey, this is pretty easy, right? I mean, come on, we've done this. Well, the reason we did 1 and 2 is really to set up now these pre-calculus examples that we're going to start seeing here in number 3, okay? And it's, you need to pick up on what I was doing there with the GCF between x3 and x2, the GCF between x6 and x8. Right, so, what if I did, and I'm just making this up, x to the 10th with x to the 7th? What's the GCF there? What's the GCF between x to the 10th, right, which is 10 x's, with x to the 7th? All right, what's the greatest amount of x's you can take out from both terms? 7 here. 7 there, right, is x to the 7th. The GCF in number 2 between x6 and x8 was x to the 6th. The GCF in number 1 with x cubed and x squared was x squared. What if, I'm not going to draw it draw out all these x's, but what if, another example here, what if I did x to the 99th power and x squared? What's the GCF between x to the 99th power and x squared? What's the greatest amount of x's you can take out from both terms? It's not 99. I'm not drawing that. I don't feel like I'm not writing 99 x's. Right? It would be x2, right? x2 is the greatest amount of x's you can take from both terms. So what's the pattern here? In each of those 4 examples with x's, right, for the GCF that I just talked about, what's the greatest, amount of x's here for your GCF? What was it always? Right? Between x3 and x2, it was x2. x6, x8 was x6. x99, x2, x was x squared. x to the 10th and x squared was x squared. Wasn't it the smaller of the two, right? For the GCF? It was the smaller of the two. The exponents was the GCF, right? x3, x2 was an x2. x2 is smaller. It's the smaller one, right? And I want you to think about that as we move forward. When you're doing a GCF with variables, you take the smaller of the two out. That's your GCF. All right, so keep that in mind. Here, as we do number 3. All right, so I'll do number 3 here. Maybe I'll do it on the other side. I think I will. Yeah, so number 3, we're going to kick off on the other side here, but, think about it, right? You got an x5 with an x negative 3. Your GCF there, remember, you're taking the smaller of the two out, right? We're going to use that rule, right, for the GCF there.